Hello everyone, my name is Mark Tendai. I'm a certified private pilot flying with and at Lewis University and Lewis University Airport respectively, and in today's video we're going to be going over magnetic compass errors. If you're a continuing viewer for my aviation series, thank you for continuing, and if you're a new viewer, enjoy. Welcome to the Loud Keyboard channel. So what are going to be the acronyms that we will remember for the magnetic compass errors? Well, there's only one, and it's DV-MONA. It goes over deviation, variation, magnetic dip, oscillation, northern southerly turning errors known as UNOs, and accelerate north, decelerate south speed errors known as ANDs. Obviously these will be timestamped below, and if you want to go ahead and skip to some, you can. If you want to take notes, I highly recommend you would. First, we're going to start with deviation. So quoted on the top right, all these are sourced from Chapter 8 of the P.A.V.E, quoted Understanding Flight Instruments. But going back to deviation, this is caused by the aircraft's electronics producing electromagnetic fields distorting magnetic compass reading. So obviously our magnetic compass is trying to read the magnetic field that is produced by the northern or southern pole. So if there's any electronic field or electromagnetic field distorting that, that will cause an error. And usually we have to correct for this using a deviation card. These look like this, and they're usually calibrated by an AMT, an aviation maintenance technician. And you just sometimes maybe if you're on a direct north heading 360 and you want to go actual north, you have to steer for 358 using the magnetic compass. Variation, what is and how to correct for it. So variation is more of a terminology, is the difference between true and magnetic directions. This is called aviation, or variation. So what are you going to know about variation? So we have agonic and isogonic lines. Isogonic lines are the lines of zero, and agonic are everything else. So in aviation, we usually do things with 360 if we do like a circle. If you split the Earth into 4 quadrants, those are going to be the isogonic lines, so there's the zero lines that separate those, and the agonic lines are all the other ones. So this is an agonic line, it's 4 degrees west. Now what does the west mean? Well, if you're west of the zero, which is this, you might have to add to correct for it, so you might have to add on your true heading for private or instrument cross-country planning. If you're on the isogonic lines, you don't have to add or subtract because you're already on that heading. So if you're west, if it says something number west, you're going to have to add. If you see something number east, you're going to have to subtract. What is and how to correct for a magnetic dip? So the closer you get to a pole, the magnetic compass will read incorrectly. So as you get closer to these fields in the northern or southern hemisphere, the compass might tend to steer towards that pole instead of on your actual heading. So your ground track might say that you're heading directly west, but if you're so close to the pole, the magnetic field might affect the compass so powerfully that it will just say you're directly north or south. So usually once you get close enough to this magnetic pole, which is shown here, obviously it moves because the magnetic force shifts in the Earth as weather patterns, as the rotation affects the magnetic force field of the Earth. Obviously we have 2 different types of true north and true souths, and we have 2 different types of north and south. We have the magnetic north and true north, sorry. We have magnetic north, true north, and magnetic south and true south. So magnetic shifts and true stays the same. Obviously, it's not going to change. So what is and how to correct for oscillation? So oscillation, quoted for Chapter 8, is the fluctuation of the compass card in relation to the actual heading of the direction of the aircraft. This is turbulence. This is mostly the turbulence errors. So obviously these sit in a liquid. These compasses sit in a liquid. That is usually called kerosene. So why not water? Well, it has a really low freezing level. I think it's 32 degrees Fahrenheit or something. I don't know. Kerosene is usually a little higher than that, or a little lower. So you can be in a much colder environment, but your magnetic compass will still function. What is and how to correct for the turning errors? So these are the most difficult ones to understand, but I'm going to try to explain it as clearly as I can. So basically the magnetic compass is going to want to remain facing that pole. Remember, once reading the magnetic dip error, if you're really close to the pole, it might just want to stay to the north. This also affects turns. This is the north or south turning errors. So note that the northern turning errors and the acceleration errors, the northern errors affect the north and south, the acceleration affect the east and west mainly. So if you're turning from the north in the northern hemisphere for this example, it's going to lag because it wants to stay to that north heading. If you're turning from the south, it's going to want to overshoot that and go back to that north heading prematurely. So if you're turning from the north, you might want to overshoot a little bit. If you're turning from the south, you might want to lag the turn. This doesn't actually happen on the direct east or west heading for whatever reason, but it will happen if you're near it. Obviously, pilots aren't perfect and there's wind. But just know that on the direct north or south heading, when you turn, it might show an incorrect reading depending on which hemisphere you're in. Obviously, this is reversed in the southern hemisphere. And what is and how to correct for the acceleration errors. So it's pretty similar to those turning errors, but this one is more an inertia force of the acceleration or deceleration causes a swing towards a pole. So this is the same example, same little diagram. This is the east or west error. So the turning error is the north or south. The acceleration is east or west, always. Doesn't matter what hemisphere. If you turn in the northern hemisphere, or if you accelerate in the northern hemisphere on a west or east heading, it's going to want to show a turn towards the north. Obviously, you're not going to do what you do here and try and lag or try and lead the turn if you're not turning. If you're accelerating, you're just going to stay where you are. But you just have to understand that this is an error that happens where it tends, just due to inertia, to turn yourself towards the pole depending on which hemisphere you're in. This example is the northern. This doesn't happen on a direct north or south heading because you're already on that heading, and if you accelerate on the north heading, this is more of a tend of the compass to shift its position. So if you're on the north and south, it doesn't really have a position to shift to. If you're on the east or west, it still has the tendency to want to turn towards the north. But if you're on the south, it's still kind of like on that direct zero or direct radial from the magnetic north or south, whichever one you're on. It still is on that certain radial, so it doesn't really have a position to shift to. But if it's on that east or west, it can still shift. So it can happen on direct north or south. Obviously, it can happen near it, just like the other errors. But just know that your magnetic compass is kind of unreliable sometimes. So obviously, we got deviation, which is mostly force fields. We got variation, which is more of a terminology. We got magnetic dip. Just you get closer to it, it's gonna have an error. You got oscillation. It's mostly just turbulence and general errors combined, I would say. We have the turning errors, which you will have to correct for in flight. Obviously, in northern, you might want to overshoot the turn. South, you might want to lag it. If you're accelerating on the direct east or west heading, just know that it might show a turn trend towards the west or towards the north, and if you're decelerating very rapidly, it might show a turn towards the south. So if you liked this video, obviously give it a like and potentially subscribe. I will be posting more videos as I get more knowledge and further on in my career, but for those who just want to subscribe, obviously I would thank you for doing that, but for a general goodbye, hope you guys enjoy the rest of your day.